Good morning, students. Today's class is about gravitation. Now you all have the basic idea about gravitation. What is gravitation? Gravitation is the force of attraction between any two bodies in the universe. I repeat, gravitation is the force of attraction between any two bodies in the universe. And there is law of gravitation also, which states that the force of attraction between any two bodies is directly proportional to the product of their mass and is inversely proportional to the square of the distance acting between them. Right? Getting me? I repeat the law. The law of gravitation states that the force of attraction between any two bodies in the universe is directly proportional to the product of their masses and is inversely proportional to the square of the distance acting between them. Done? Now, whenever we have mentioned in previous classes that whenever there is a law, if there is a mathematical statement, mathematical explanation of the law, we must go through it and we must write the mathematical expression also alongside with the law, with the statement, right? So let's see the mathematical statement of gravitational law. Fine. Now we are discussing about the mathematical statement of gravitational law. Let's see. Suppose M1 and M2 are two bodies separated by a distance r. Then force of attraction between them, F, is directly proportional to the product of their mass and is inversely proportional to the square of the distance between them. So combining these two, we get F proportional to M1 M2 by R square. That is F equal to G M1 M2 by R square. F equal to G M1 M2 by R square. That is the mathematical statement of the law. Now what is G? G is gravitational constant. G is gravitational constant. This is okay for junior level and the value of G is 6.67. I repeat, 6.67 into 10 to the power minus 11 Newton meter square kg minus 2. And the dimension of G, that is SI, value in SI unit, and the dimension of G will be, since Newton, ml cube, so divided by m square, so we have m L t to the power minus 2 into L square divided by m square. That is the dimension we are talking about. So this becomes m to the power minus 1 L cube t to the power minus 2. That is the dimension of gravitational constant. Gravitational constant is numerically equal to the force acting between two bodies of unit mass separated by a distance. What do you mean? If suppose we are getting G equal to, from the previous expression, F R square by M1 M2. Now if we take M1 equal to M2 equal to 1 and R is also 1, then we have G equals to F. So you can say that gravitational constant is numerically equal to the force acting between two bodies of unit mass and separated by unit distance, then gravitational constant becomes numerically equal to the force acting between them. This is okay for the junior classes. For class 11 physics, there should be or there must be a vectorical representation of this law. Why, sir? Because force is itself a vector quantity. So you have force equals to G m1 m2 by modulus of r square into a unit vector along the straight line joining them, right? You can also write this like that: G m1 m2 r cube into r vector. Why, sir? Because you know that unit vector r or r cap equals to r vector divided by its magnitude. So this is the final expression for the force acting between two bodies of mass m1 m2 separated by a distance r. Fine. And now there are one or two more things. So if now there is one more thing, that is gravity. Now what is gravity? What is gravity? Sometimes we may get confused with gravity and gravitation. Gravity is a special case of gravitation, mind it. Gravitation is the force of attraction between any two bodies in the universe. Now, if one of the attracting bodies becomes Earth, then it is called gravity. Gravity is a special case of gravitation where one of the two attracting bodies is Earth. So, gravity is the attraction between Earth and any other body, right? Now, let us see mathematically. What do I get? If is the mass of Earth, capital M is the mass of Earth, and small m is the mass of any other body, and the distance, suppose the body is at the surface of the Earth, so radius is the distance. Suppose any person, as well as you may consider me, I am standing here at Earth's surface. So I feel an attraction, and that attraction gives me acceleration. That acceleration due to gravity, g. So mg equals to, you have g m by r square. Mg equal to g by r square. That small m cancels. So you have g equals to g m by r square. That is the relation between acceleration due to gravity and gravitational constant. So at Earth's surface, you know that g equals to 9.8 meter per second square. Fine. Now, in the future classes, we will see that on which factors g, that small g, depends. Capital G is constant everywhere, but small g, acceleration due to gravity, changes from place to place. It is different at different places of Earth, as well as it is different if we go above Earth's surface or if we just go below the Earth's surface. Suppose in coal mines, in all cases, the small g varies, and the dependence of small g with, suppose, height from the Earth's surface, the dependence of small g on depth, how far we just go below the Earth's surface, or at even different places, or you can say the dependence of g on diurnal motion or rotational motion of Earth. We will discuss all these. On all these factors, the acceleration of due to gravity varies, depends. How? That will be discussed in future classes. Thank you.